Hey class, happy snow day. Yes, it's 2014 and we have a snow day before Thanksgiving. So quickly we'll try to get this video made on dividing polynomials, section 6.2, so that you can get out in the snow as soon as possible. And my daughter's cat, Javier, is here to help us. He's sitting on the footstool, extremely excited, you can tell by his expression, to hear us discuss polynomial long division. Now, you may not realize it, but you've really already started long division. On the screen, you can see 4x plus 2 over 2. Already you know how to do this. You would say, well, 4x divided by 2 is 2x, and 2 divided by 2 is 1. That was polynomial long division in one of its simpler forms. You could have written it like this. 2 goes into 4x plus 2, and you would say, all right, 2 goes into 4x how many times? When I say that, what I mean is, what would I have to multiply 2 by so that my answer is 4x? Well, I would have to multiply 2 by 2x. So I put a 2x up here, and then I say 2x times 2 is 4x, and then I subtract to get 0. Bring down the 2. And then the next question is I just repeat. How many times does 2 go into 2? Or 2 multiplied by what is 2? Well, the answer, of course, is 1. I put my 2 down and subtract, and I get 0. And that is a simplified example of what we are going to be learning at today. I hope that what you will do is open up your book to page 341, that you will start reading and be taking reading notes as we go through, and I am going to explain each example as we go. All right, example 1 is dividing a polynomial by a monomial. Now remember that a polynomial means more than one monomial. So here's your polynomial, here's your monomial. This is the kind of division that you're already familiar with. In the example, it shows that when you divide, you have to take the monomial in the denominator underneath each of the terms in the numerator. Once you do that, you take the 6 divided by 3. So in other words, you're taking the integer value divided by the integer value. Then you subtract the exponents on the x's. So it's x to the 4th over x to the 1. You subtract 4, take away 1. The same with y to the 3rd over y. That's y to the 3rd, subtract y to the 1. Remember that when there is no exponent on the variable, it is 1. So all of these are 1s down here, and you will be subtracting those exponents because that's how you do division with exponents. So you repeat the process for each. You have 12 divided by 3. You have 18 divided by 3. You subtract your exponents, and then that is your final answer. I think probably most of you are pretty comfortable with this. Pause the video and do 2A and 2B. I'm going to write the answers down here and see if that's what you got. And good luck. All right, check your progress. 1A was a little bit tricky. Okay, right away in check your progress 1A, if you ran into something a little different, they did throw something at you a little different. I want to just go over it really quickly. You start with 20 divided by 4, which is 5, and then C, the power of 4 subtract 1 is C to the 3rd. 2 on the D's, the exponent is 2 and 1, so that's D to the 1. And then notice F has 1 and 1. When you subtract that, you get F to the 0. What is F to the 0 power? F to the 0 power is just 1. So you end up with just a 1 for f, which means with multiplication, since these terms are being multiplied together, you'd be multiplying by 1, it disappears per se, because you just don't need to include it. So if we continue on to the next one, subtract 16 divided by 4 is 4. And again, you've got c to the 1 over c to the 1, which just becomes 1. This becomes 1. And since we're multiplying these together, we don't need to include them in it. And then we've got f squared over f to the 1, which when you subtract those, you just get f. Then for our last term, notice that everything divides. 4 divided by 4 is 1, c divided by c is 1, d divided by d is 1, f divided by f is 1, so that last term is 1. Make sure that you include that last term. It isn't 0, it's 1. In your Check Your Progress 1B, they also throw something a little different at you. They give you 3xy, the quantity to the negative 1. What does that mean? An exponent with the negative 1 means put it in the denominator. So this becomes 3xy down there, and you can then say essentially, of course it's not going to let me erase the original, so I'll just cross it out and you get the idea. There we go. So you just put it in the denominator and divide like usual. I hope that you got 6x plus 9x squared yz. All right, on to example 2. Okay, we're on to example 2, and your first question might be, why are we suddenly changing up the method? Why don't we use the same method? Why don't we put x squared over x minus 5 plus 3x over x minus 5 minus 40 over x minus 5. Well, I think it bears, it's important to note, if you do that, you could do that, but you can't subtract your exponents the same way, because suddenly you no longer have a monomial in the denominator, but you now have a binomial in the denominator, and things just don't work the same. So you have to set up a long division problem. The way that you do it is you take the highest degree here, which is x, and you say x to the first power multiplied by what gives me x to the second? Well, x times x. So you put that up there, x. That's what I multiply this exterior x by to get my interior x squared. I now take this x and I multiply everything on the outside by it, and I line up my terms. So x times x is x squared, x times negative 5 is negative 5x. Key point here. Next, you always, always, always subtract. So x squared subtract x squared, those cancel out. 3 subtract negative 5 is 8x. I bring down my next term, negative 40. Now it's like the directions on a shampoo bottle. Have you ever watched them? Or have you ever read them? It says, lather, rinse, repeat. Lather, rinse, repeat. And you want to do the same thing here now. You're just going to repeat the process that you started in the beginning. X multiplied by what gives me 8x? Well, that would be 8. So I put an 8 up here. And then I multiply 8 times everything on the outside. 8x minus 40. And then I remember that I am subtracting. And when I subtract 8x, I get 0 and 0, which means I have 0 remainder. It also tells me that if I take x squared plus 3x minus 40 and I divide by x minus 5, my answer is x plus 8. What else does that tell me? It also tells me that x plus 8 times x minus 5 equals x squared plus 3x minus 40. If I were to put, a good way to check your work is by using your calculator. You could enter this right here as y1, as long as you put parentheses around both the numerator and the denominator, and this as y2, then go to your table and all your values should be the same. Or you could enter this as y1 and this as y2. Go to your table and all your values should be the same. All right, pause and go ahead and check your progress in your notes. Check your progress. 2a and 2b seem pretty straightforward. You should have gotten x plus 10 for 2a and x minus 12 for 2b. I hope that it went well for you. On to example 3. Standardized test example 3. What they're doing here is they are trying to help you understand that when you have something to the negative 1 power, it's the same as putting it in the denominator, which means since you have a binomial in the denominator, that you have to set it up as standard long division. Also note that since the a is negative, you have to ask yourself, negative a times what gives me a squared, and that's negative a. And then you multiply negative a times negative a is a squared. Negative a times 3 is negative 3a. And then you subtract. That's what this minus sign is here for, subtract. So this time, the only thing that's different is you now have a remainder, the remainder of 19. So they go down here at the bottom. They say the quotient, which means the answer to a division problem, is negative a minus 10 with the remainder of 19. Therefore, if you take the original and you divide, you get this answer. What is this? Now, they took the remainder and they put it on top of what you were dividing by. Now, you might think that that is pretty strange. However, think about this. Just change your perspective back to regular division. If I take 17 and I divide by 5, what do I say that that is? I say it's 3 with a remainder of 2. So another way to also represent this is my answer is, whoops, just a minute. My answer is 3 and 2/5. Notice we put our remainder in the numerator and what we were dividing by in the denominator. And we don't often think of this, but really that is 3 plus 2/5. Isn't that the same thing as 3 and 2/5? So when they write their answer down here, they say it's negative a minus 10, and then they add the remainder divided by 3 minus a. Interesting. Go ahead and try to check your progress. In example 4, we suddenly move to synthetic division, which looks very different than the polynomial long division we've been looking at. Now, in order to explain the difference, I'm actually going to switch to another screen, and we're going to first of all use this example with polynomial long division, and then I will show you how to do it in synthetic division. Okay, let's look at this example that they have in the book, and let's just use long division like you've already been doing. First of all, I compare my x with my 2x to the third, and I say I would have to multiply by 2x squared. So I multiply and I get 2x to the third here, and then I get negative 8x squared, and of course I remember that I need to subtract. And so I do that, And when I do that, these cancel out. Negative 13 subtract negative 8 is negative 5x squared. I bring down my next term, and I say, what do I need to multiply x by to get negative 5x squared? Negative 5x. So that's negative 5x squared plus 20x. Again, I remember that I'm going to subtract. And when I do, this cancels out, and I get 6x. I bring down my negative 24. X multiplied by what gives me 6x? Well, it is 6, and so that gives me 6x minus 24. Again, I remember that I subtract, and when I do, that gives me 0 remainder. So, that is long division. When you take 2x to the third minus 13x squared plus 26x minus 24, and you divide by x minus 4, the result is 2x squared minus 5x plus 6. Or I could say, if I take x minus 4 and I multiply by 2x squared minus 5x plus 6, my answer is right there. I'm not going to rewrite it all out. It's kind of hard to do with a stylist. Alrighty tighty. Now, what is the difference between long division and synthetic division? Alright, synthetic division. What is the difference? First of all, there is a reason I kept writing subtraction, subtraction, subtraction. It's because long division is based on subtraction. Synthetic division is based on addition. So that is one important note or difference to note. Also, synthetic division can only be used if you're dividing by x minus c. Now, what do I mean by that? X has to be to the first power, and the coefficient is 1 in order to use synthetic division. For instance, in long division, you can divide by anything. You could have taken 2x to the third minus 13x squared plus 26x minus 24, and you could have divided by 5x squared plus 1. It doesn't matter, it works. Here, you can only use synthetic division when you're dividing by a binomial who has the variable value of to the first power. Whoops, I didn't mean the 11th power, I mean the first power. All right, now, how is it different? First of all, since we are dividing by x minus 4, the first thing that we do is we write 4 in a little box. Now 4 is the actual location of the 0. It's also the opposite of the integer in my factor binomial. All right. Now I list all of the coefficients of my polynomial. The coefficient of x to the third is 2. The coefficient of x squared is negative 13. Coefficient of x is 26. Coefficient of x to the 0, or my constant value, is negative 24. So I have listed my coefficients. Notice I have to have a coefficient for every power. I have x to the third, I have x squared, I have x to the 1, and I have x to the 0. If I didn't have one of these values, I would have to put a 0 in as a placeholder. Next, I drop my 2 down to start. Now I multiply 4 times 2 equals 8, and I write that here. And I add negative 13 plus 8 is negative 5. Did you see a negative 5 over here anywhere? Yes, you did. Now I just, like the shampoo directions, lather, rinse, repeat, I repeat this process. 4 multiplied by negative 5 is negative 20. I add. 4 times 6 is 24. I add. This is my remainder. This is my coefficient to x to the 0. This is my coefficient to x to the 1. This is my coefficient to x squared. So what is my answer? 2x squared minus 5x plus 6. I'm sorry. No, plus 6. There we go. Remainder 0. At first it seems a little confusing, but it really is pretty simple once you get used to it. I think it would be good for us to do Check Your Progress 4A together. If you look at it in your book, what will we put in the little box? Negative 3, because that's the opposite of what's in our factor group and is the actual location of the 0. Next, we list all the coefficients of our polynomial. So that's 2x to the third, 3x squared, negative 4x, and 15. All right, next step. Drop the 2. Multiply, add, multiply, add, multiply, add. So negative 3 times 2 is negative 6. Add, you get negative 3. Negative 3 times negative 3 is 9. Add, you get 5. Negative 3 times 5 is negative 15. You get 0. This is your remainder. This is your constant, or x to the 0. This is your coefficient of x to the 1, and this is your coefficient of x squared. So what is your answer? 2x squared minus 3x plus 5. Remainder 0. So you can see, once you get used to it, it's not that bad. On a side note, this is not in this section, but just so you know, if you were to take x squared minus 9 and divide by x minus 3, and we were using synthetic division, we would say 3 goes in the box. We would say the coefficient of x squared is 1, the coefficient of x is 0, and my constant is negative 9. Notice we have to put the 0 in for the x to the first power. We have to have a coefficient of each power of x. So I drop the 1. 3 times 1 is 3. I add. 3 times 3 is 9. I add. So my answer is x plus 3. This shouldn't be shocking to you because you know that x minus 3 multiplied by x plus 3 is equal to x squared minus 9. All right, pause the video and do your other Check Your Progresses. Okay, these are the answers to the Check Your Progress. If you got something different for 4C and 4D, be careful, because when you set up 4C, you put negative 2 in the box, and then you need to have the coefficient of x to the 4th is 4. The coefficient of x to the 3rd is 0. X squared, 2. X to the 1, negative 4. X to the 0, 12. And by x, of course, I mean a. Not important. So be careful, careful, careful. The same is true in D. All right, let's move on. All right, example 5 is a little monstrous. I want to get a fresh screen here and show you how to do example 5 in 2 different ways and explain what they're doing. They are rearranging this 3x plus 1 so that they can use synthetic division. Remember before when I said to use try that again. To use synthetic division, you have to divide by x minus c so that your variable has the coefficient of 1 and it has the exponent of 1. So what they've done is they've divided this by 3 so that they can use synthetic division. Then when they're done, they are fixing it back up, and that's what this process is all about. So let's discuss this on a different screen. What they don't show you in this example is that you could just do this problem with regular long division. So we're going to start there. If I use regular long division, I would say, all right, 3x multiplied by what gives me 3x to the 4th, and that's just x. So I would put it's x to the 3rd. So I would multiply x to the 3rd times 3x and get 3x to the 4th plus x to the 3rd. Remember that you are always using subtraction when you use long division. So I subtract. 5 subtract 1 is negative 6x to the 3rd. I bring down my next term. I need to multiply this by negative 2x squared. That gives me negative 6x to the 3rd minus 2x squared. And I subtract. This cancels this out. 1 subtract negative 2 is 3x squared. I bring down my 7x. 3x times what is x squared? And that would be positive x. And that gives me 3x squared plus x. I subtract. And 7x subtract 1x is 6x. Am I done? No, because I still have an x here, and x is the same as what I'm dividing by. 3x goes into there how many times? 2 times. And so I have 6x plus 2. Now above my 2 I have a 0. I still need to subtract. And so when you subtract, of course, you're going to subtract, you get negative 2. And so your answer is x to the 3rd minus 2x squared plus x plus 2 minus 2 over 3x plus 1. All right, now what your book does is it says, let's not use long division, let's use synthetic division. But in order to use synthetic division, we have to be dividing by x minus c. So in other words, they want to change that 3x plus 1 into having x to the 1st power. Well, to do that, you have to divide by 3, but to keep everything balanced, we have to divide both the numerator by 3 and the denominator by 3. So when you divide your numerator by 3, just a minute, my cat's going crazy. Okay, so you have to divide both the numerator and the denominator by 3, which leaves you with x to the 4th minus 5/3 x to the 3rd plus 1/3 x squared plus 7/3 x, and then you will be dividing by x plus 1/3. All right, so we set up our synthetic division. We put negative 1/3 in the box. We put the coefficient of x to the 4th, then the coefficient of x to the 3rd, then the coefficient of x squared, and then the coefficient of x. We also have to put a 0 for our coefficient of x to the 0, or our constant term. We drop the 1. We multiply, and we add negative 6/3, which we know is negative 2. We multiply, and that is negative 2 times negative 1/3 is positive 2/3, and we add and we get 1. Negative 1/3 times 1 is negative 1/3, and I don't know why I wrote an x under here instead of a 3. Let me fix this. And we add, and that gives us 6/3, which is 2. And then we multiply. Negative 1/3 times 2 is negative 2/3. And we add, and we get negative 2/3. So our answer, when we've divided by x plus 1/3, our answer is negative 2/3 is our remainder, so we put that over what we were dividing by, and then of course 2 was our constant, and I think I'm going to erase this little negative sign up here and write it as subtraction. 1 is the coefficient of our x value, negative 2 is the coefficient of x squared, and 1 is the coefficient of x to the third. Now, compare this and this. The only thing that we need to do is work on simplifying that. 2/3 divided by x plus 1/3. Now, the only way we can divide this is if we change it into one fraction divided by one fraction. To make this one fraction, I need to come up with a common denominator. So I'm going to multiply x over 1 by 3 over 3. So when I have 3 over 3, what I have over here is 3x over 3 plus 1 over 3, which gives me the fraction 3x plus 1, all of it over 3. So now when I go to divide, I can say this is 2/3 divided by 3x plus 1 over 3. And if you remember your fractions, when you divide a fraction, you actually multiply by the reciprocal. So that's 3 over 3x plus 1. When I multiply that, I cross-cancel my 3's, and that leaves me with 2 over 3x plus 1. And that does indeed match my last term there. So again, I really honestly do not care whether you use long division or synthetic division on problems like this. That's really up to you. Okay, pause the video and do check your progress. Okay, these are the answers to check your progress. One thing to note, on 5A, if you were using long division, okay, you may have run into an issue because you're taking 2x plus 1 and you are dividing into 8x to the fourth. Notice that there is no x to the third. You might want to put a 0x to the third minus 4x squared plus x plus 4. Why would I want to do that? Because when you start this multiplication, you multiply 4x to the third, that gives you 8x to the fourth, and then you have plus 4x to the third, and you need some place to put it. Some of you may have put it underneath of the x squared, but remember you can only subtract like terms. So when you do this subtraction here, you end up with negative 4x to the third minus 4x squared plus x plus 4. And then you continue on. So just be aware of that, that you make sure you're lining up variables of the same degree. one last thing before we're done. I just wanted to show you my personal division for Check Your Progress 5C. And then I also wanted to show you how you can check your answers on these. This is how I checked my answer. In my calculator for Y1, I put this part of the equation. And for Y2, I took what I was dividing by, multiplied by my answer, adding my remainder over the 5b minus 4 in parentheses. Then I went to my table and I checked my values, and I had the same values in both sides of my table, so I knew that I had done this work correctly. Good luck. I will see you soon with any questions that you have. We're done with 6.2.